Hello everyone, I am Siti Aliyah Jan Abdul, and for today's video, we're gonna talk about Activity 8, Test for Acid and Base. For the objectives, first, to know what is acid and base and some of its theories. Second, to learn the difference of acid and base. Third, to know what is pH scale. And lastly, to learn the neutralization reaction of acid and base. So without further ado, let's start. For the theories, Arrhenius theory, introduced in 1887 by the Swedish scientist Svante Arrhenius, that acids are substances that dissociate in water to yield electrically charged atoms or molecules, called ions, one of which is a hydrogen ion, and that bases ionize in water to yield hydroxide ion. The second theory is the Bronsted-Lowry theory, also called proton theory of acid and bases, a theory introduced indefinitely in 1923 by the Danish chemist Johannes Nicholas Bronsted and the English chemist Thomas Martin Lowry, stating that any compound that can transfer a proton to any other compound is an acid, and the compound that accepts the proton is a base. What is an acid? It is a chemical that gives off hydrogen ions in water and forms salts by combining with certain metals. Acids have a sour taste and turn certain dyes red. Some acids made by the body, such as gastric acids, can help organs work the way they should. An example of an acid is a hydrochloric acid. So what is base? Base is a substance that can neutralize the acid by reacting with hydrogen ions. Most bases are minerals that react with acids to form water and salts. Bases include the oxides, hydroxides, and carbonates of metal. The differences of acid and base. So what is a pH scale? It is a measure of hydrogen ion concentration, a measure of the acidity or alkalinity of a solution. The pH scale usually ranges from 0 to 14. Aqueous solution at 25 degrees Celsius with a pH less than 7 are acidic, while those with a pH greater than 7 are basic or alkaline. For further explanation, let's watch this video.
Look at the pH scale and some other simple indicators of acids and alkalis. In other videos, we have seen what makes something acidic, neutral, or alkaline. We can tell if something is acidic, alkaline, or neutral by using an indicator. Indicators are substances that show different colors when they are in acidic or alkaline conditions. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus is red in acids and blue in alkalis. Litmus paper is made from lichens, which have been used to dye cloth for hundreds of years. It can be used as a liquid or paper. The paper is easier and more reliable. It comes as red litmus paper and blue litmus paper. Red litmus paper changes colour from red to blue under alkaline conditions, but no change under acidic conditions. Blue litmus paper changes colour from blue to red under acidic conditions, but no change under alkaline conditions. So just remember that red litmus paper changes colour for alkalis, and blue litmus paper changes colour for acids. However, litmus paper only tells us whether something is acid or alkali, but it does not tell us how acidic or alkaline a substance is. For this, we have the pH scale and a universal indicator. Universal indicator is a mixture of different indicators, or dyes, which has many different colour changes, and so shows us the pH value of the solution. Again, it can be used as a liquid or a paper. The pH runs from 0 to 14, with 0 being extremely acidic, 7 being neutral, and 14 being extremely alkaline. Stomach acid is a strong acid with pH of about 2. Acid rain has a pH of about 5.5. Milk is neutral with a pH of 7. Seawater is a slightly alkaline. Soapy water is a strong alkaline. And bleach is a really strong alkaline with a pH of 13. Universal indicator is so called due to its ability to indicate the entire pH spectrum. There are other indicators that can be used that have other color changes, but these two are the ones you need to know. We can also get even more accurate measurements of pH using a pH meter, which will give us readings to 0.01 of the pH. So from this lesson, you should now know indicators can tell us whether something is acidic or alkali and how acidic or alkali it is. Red litmus paper changes colour for alkalis, and blue litmus paper changes colour for acids. And universal indicator can give us more detail, indicating where on the 0 to 14 pH scale a solution is. Acids are from 0 to 6.
For the neutralization reaction, let's watch this video.
If we take two solutions, one acidic and the other alkaline, and mix them, what will be the result? By now, you should be able to answer that it will give us a salt and water will be released as a byproduct. Now, does this happen every time? I mean, will an acid and an alkali always give us salt and water? Yes, it will always be like this. An acid, when combined with a base, will always give us salt and water. And what is this reaction called? Does it have a specific name? Yes, it does. It's called a neutralization reaction. Here, the strength of both the acid and the base are lowered. They are brought to a neutral point where the intensity of the acid as well as the base are dropped lower. The best example to study a neutralization reaction is the formation of sodium chloride, or simply put, common salt. If we take hydrochloric acid and combine it with sodium hydroxide, then the neutralization reaction gives us sodium chloride and water is obtained as a byproduct. The reaction also liberates a lot of energy in the form of heat. This is how every neutralization reaction works. Acid and a base combine to give salt and water with heat generation. But looking at the reaction of sodium chloride formation, you may say that neutralization only occurs in laboratories. When acids and bases are combined in a test tube in a lab, it's only then a neutralization process occurs. Is that the case? Actually, that's not the case. Neutralization reactions are a part of our daily lives as well. Many reactions occurring inside our body or even throughout the day are neutralization reactions. For example, we usually find elders complaining about acidity. Or ants biting us on the skin. These are examples where the percentage of acid increases inside or on the body compared to the normal value. Such cases are treated with medicines. But have you wondered how these medications work? Needless to say, they work based on the principle of neutralization.
Generalization: acid and bases can be found not only in the laboratory but also in our everyday life. Except for water, it is in everything we eat and drink. It is critical to understand and recognize the distinctions between acid and base, since mixing the two will result in a reaction. It has the potential to release hazardous gases or explode.